Okay, so I'm going to have my Cartesian plane. I know that this is quadrant 1, quadrant 2, 3, and 4. I know that this is cos only positive, all 3 are positive, sine only positive, and tan only positive. Sorry, what else do I know so far? I know that this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and this could become 360 as well. The first reduction formula that we learned a few weeks ago that we didn't even know was a reduction formula was that 360 plus theta is the same as just theta. And because sine, cos, and tan are all positive, they would all be positive theta. So remember that we need to check those quadrants every time we do something in a new quadrant. Check positive or negative in the quadrants. We learned that yesterday 180 minus theta. We learned 180 plus theta. We learned that this was 360 minus theta. But we also know it to be negative theta. Sorry, I was going to take that equals away there. I'm just writing it lower so I have more space. It's the only thing I'm doing. So those are the reduction formula that I could use. Okay? Now I wrote here, and we mentioned it yesterday, that we need to check, is it positive or is it negative? And the reason why we need to check is because of the curving nature of that function. Okay, so we know that the value will be the same, but it might be positive, it might be negative, and that depends on the quadrant that it's in. So when I look at my reduction formula for sine, cos, and tan in every quadrant, this is what we should be seeing. 360 plus theta I'm going to write in pen just so it's a little bit thinner. Mostly, yes. 360 plus theta. Sine is positive or negative in this quadrant? Positive. So it would be the same as just saying sine theta. So whatever that theta was, that's the theta there. Not plus theta. Remember that plus doesn't give me any kind of indication of plus or negative, plus or minus. That is only based on the quadrant. The quadrant tells me that it's positive. So if I had cos 360 plus theta, is cos positive or negative? Positive. So I can reduce a larger angle to positive cos theta. And the same thing is repeated for tan. Also positive in that first quadrant. So I can reduce it to just tan theta. It will give me the same exact answer. So if I have, say, for instance, 500, that would be the same as positive sine 140. Because the 140 is what got me to the 500. That's my first quadrant. My second quadrant will start with sine 180 minus theta. We'll also have cos 180 minus theta. And there could potentially be a tan question in this quadrant, which would also be tan 180 minus theta. Now, sine is positive or negative? Cos, positive or negative? And tan? So even though it might be a weird angle between 90 and 180, I can reduce it to a smaller acute angle, and then it will be positive for sine or negative for cos and tan. Let's do it in our third quadrant. Sine 180 plus theta. Is sine positive or negative? Cos 180 plus theta, positive or negative? And tan is positive in that quadrant, so it would be the same as just saying positive tan theta. And lastly, we have sine 360 degrees minus theta. Is sine positive or negative? Cos 360 minus theta, positive or negative? Positive. And tan, sorry, it looks terrible. 360 degrees minus theta, positive or negative? Negative tan theta. But remember, we did those negative angles as well, right? A couple weeks ago. We said that we could go sine negative, but because it's a positive cos, sine, we can take the negative out. We can have cos negative, but because cos is positive, when we take it out, it becomes positive cos. And tan negative theta, when it takes it out, because tan is negative, it is also negative in that quadrant. So that pretty much sums up most of what we've learned so far about trig. So what I'm going to do now, only about 4 or 5 questions, I'm going to ask you to reduce the angles to the acute angle. Sometimes I'm going to leave it as theta, then your answer will just be tan theta. But sometimes there's going to be numbers involved, and I want that smaller acute number according to your reduction formula. So very much like what we did yesterday. I'm just looking for my start. This, yeah. Okay, so my question is to you. Reduce the following to acute angles. So I'm just waiting for Erin to finish. And I'm giving you a helpful hint here, which I obviously would not do in a test. Check that your quadrants are correct. Your signs in your quadrant. Okay, I'll show it to you in a second. Just writing one more question. Okay, 7 for you to practice. They should really not be too difficult. So what I mean by checking your quadrant signs, let's do one together. So I have sign 250. In which quadrant would 250 be? In the third quadrant. What is my reduction in that third quadrant? 180 plus. So what am I adding to get to 250? 70 degrees. So my reduction would just be sine 70, but check it in that third quadrant is sine positive or negative. So it has to be negative sine 70. So I want you to do that with all of them. You will not be using a calculator for this. Unless you can't do the pluses and minuses, that's okay, but I don't want any decimals or anything, okay? So if you're not confident in your plussing and minus, okay, but I don't want you to calculate the angle. Just do the reduction. My phone is ready. First step is check which quadrant. Second step, use that quadrant's reduction. Third step, is it positive or negative? And then get that angle. One more minute. I'm more interested than you've done 1 to 6, 7 we can do together. Okay, let's have a look. So, negative theta is in my fourth quadrant, so I'm even going to draw a little quadrant for myself here. A little cast diagram. I know I'm writing smaller, thinner pen. This would be 180 minus theta, 180 plus theta, 360 plus theta, 360 minus theta, or minus theta. Okay, so when I do this kind of question, I'm always going to draw that for myself, because I'm always going to keep double checking everything according to that cast and reduction plane. So my first one, I know that it is going negative. Cos is positive in that quadrant, therefore it's cos theta. Tan, 195. 195 is in my fourth quadrant, and that quadrant is 180 plus theta. And tan is positive in that quadrant. Now I need to find what it is that I need to add to 180 to get to 95. 15 degrees. So my reduction is positive tan 15 degrees. My next one, sine 135. 135 is in my second quadrant, which is 180 minus theta, and it's my second quadrant, so sine is positive. What do I need to minus from 180 to get to 135? Can't hear you. 45. So it would be the same as saying positive sine 45 degrees. Next one, cos 390. 390 would be back in my first quadrant, so that is 360 plus is the reduction. Cos is positive in that quadrant, and I'm adding 30 degrees to get 390. Therefore, my reduction is positive cos 30 degrees. And the last one of the easier ones, 150, is in that second quadrant, which is 180 minus theta. Tan is negative in that quadrant. What do I minus to get to 150? I minus 30 degrees. So that would be the same as saying negative tan 30 degrees. Henry. It was an accident, to be honest. So brackets, no brackets, is okay. So once you know your reduction formula, it's actually not so difficult. Yes, Courtney? Number 2. So everything we measure actually goes into that direction, a positive angle. So as soon as I have a negative angle, it's going in the opposite direction, which means that it's in my 4th quadrant. But because I'm dealing with cos and cos is positive, it's positive cos theta.
And it didn't give us any numbers, but so it's just that.
Same with what we're going to see now in number 7. I don't have numbers, so I'm just going to have to leave it as theta. Okay? Now what do? I deal with each one separately. That's it. And then I will deal with a bunch of things that may or may not cancel. If it can't cancel, then that's my final answer. Okay? So sine 180 plus theta is my 3rd quadrant. Sine is positive or negative. Cos 360 plus theta, 360 plus theta is cos positive or negative? Cos negative theta going in the opposite direction, positive or negative? Sine negative theta in that 1st quadrant, 4th quadrant there, positive or negative? Just like every other fraction we have done in our lives, if we see identical stuff, we cancel it. Negative divided by negative, positive. My answer is positive 1. How can I complicate this? I can put numbers in there. I can put special angles in there, which is what we're doing next. And that's pretty much it. So I just wrote a very quick summary of how to deal with that kind of, or these kinds of questions.
Can you leave the 6 and 7?
I'm just going to zoom out just a little bit. Ask yourself which quadrant. Use the reduction formula for that quadrant. Is your function positive or negative? Find the angle, and if there's more than one reduction, repeat for each one that you see, and then after that repetition, cancel and simplify where possible. After you've written that down, please write the heading special angles.
Is there anything after that?
No, I scratched it up. Okay, special angles. Now the first bit of it you don't have to write, okay, because I just want to show you where you will get it from, okay. Special angles, I want us to compare these two similar triangles. What makes them similar? Do we remember what similarity means? They have the same angles, all the sides are in proportion, okay? So, I can see that I have a 90, a 30, and a 60 in my angles, and this is times 3, that's times 3, and that's times 3. So my triangles are similar, okay? Now I want to check, in these two scenarios, what is my sine, cos, and tan ratios? So remember, we are now dealing with triangles, so we're dealing with opposite hypotenuse and adjacent hypotenuse, not the plane, so we need to check what's opposite and all of that stuff. So, I have 60 opposite over hypotenuse. Cos of 60 is adjacent over hypotenuse. Tan of 60 is opposite over adjacent. Let's check in the other triangle. 60 opposite over hypotenuse. Adjacent over hypotenuse. And opposite over adjacent. Now, if my triangles are similar, and I have used sides that are in proportion, that means that there's a factor that exists between them, right? But shouldn't I then have those ratios simplifying to the same value? Currently, they're not the same, right? But let's simplify as far as possible. Well, firstly, I know a 3 over 6 is a half. That's equal. Square root 27 over 6. Gives me square root 3 over 2 as the most simplified answer. Square root 27 over 3, square root 3 over 1. So even though my triangles are different sizes, the fact that those angles are the same, my sine, cos, and tan will always simplify to the same values. And that is why we consider it a special angle. Because I can make a triangle 500 times bigger, but still with 60, still with 90, and still with 30. And I will still get these simplified forms of the special angle. So normally, in a normal year, I would make you memorize these ratios. But we don't have time for that. So what I am going to tell you that you need to remember that 30, or is this 60, is a special angle, therefore has a special value. You're going to check what that value is in the calculator and write it on your page. So you just need to know that as soon as you see 60, it's going to be a fraction, you're going to put that fraction in. So you literally just go sine 60 and calculator, copy the answer. So I'm not expecting you to know off by heart that sine 60 is square root 3 over 2, because that's normally what I would want you to do. All I want you to do now is, oh, it's a 60. I know that's a special angle. I'm going to check what it is. And your calculator is going to tell you square root 3 over 2. So instead of learning all the different special angles, you're just going to learn that to look for it. But that does mean you can never forget your calculator. Ever, because then you're screwed. There is no other way to say that. Let's check 30. Now, here's my 30. There's my opposite. There's my hypotenuse. There's my adjacent. There's my hypotenuse. And there's my opposite, and there's my adjacent. Simplifying. 1 over 2. Your calculator is how I checked it, was square root 3 over 2 and 1 over square root 3. Checking in my other calculator, my other triangle, from the 30 as my reference, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So if you do want to memorize something, you memorize this triangle, because you can find all three ratios from that triangle. So I'll take a picture and put it on the group because we need to look at the next triangle. Okay? So 60 and 30 are special angles. As soon as you see it, type it, write down the fraction. So that's what you can write. Special angles. 30 and 60 are special angles. There is going to be one more, which we're going to do now. Will be fraction. Find on calculator. Cut and paste with fraction. Okay, so special angles, 30, 60. The next one we are doing is 45. As soon as you see them, type exactly what you see on your calculator, cut that away and paste the fraction that your calculator gives you.
Now can you go down again after?
This is basically aimed at people who have sharp calculators.
Don't you have a, oh, but yours gives you in decimal form, so you're going to have to memorize the two triangles, you as well. It's literally just two triangles. You don't have to memorize all the ratios, because if you remember this, then you know how to find cos, tan, and sine. So the way I remember it at school, the 30 was right next to the square root of 3. And then the 1 and the 2 has to be the biggest, so that goes to my hypotenuse. And also, obviously, anyone that forgets their calculator is also screwed. So when you do have the time, I do suggest you learn this exact triangle off by heart. But I don't have the time to drill it into you now. Okay, I'm going to my next one. I'll take a picture for you for your notes. So we can therefore say that sine 60 will always be square root 3 over 2. Cos 60 will always be 1/2. And tan 60 will always be square root 3 over 1, but obviously that could just be square root 3. So when I'm talking about cutting and pasting, that is what the question gives me as part of my calculation. I cut it out and I paste that instead. So watch what I've done again, please. So stop writing and look. That is what the question gives me. I type it into my calculator, I cut it out, and I paste that instead. So my sine 60 has disappeared, and I've replaced it with the square root 3 over 2. When we do the calculations now, you will see what I mean by that. Sine 30 will always be 1/2. Cos 30 will always be square root 3 over 2. And tan 30 will always be 1 over square root 3. Here's my 45. So once again, you can either quickly get that down or I will send the picture of it. Sine 45, I've drawn two different triangles. They are similar. Right angle, 45, 45, 45, 45. What is my factor between these two? 5. Okay, so in this one, using this as my reference, 5 over square root 50. Cos would be 5 over square root 50. And tan would be 5 over 5. Simplifying. Gives me 1 over square root 2. 1 over square root 2. And 5 divided by 5 is just 1. Please note that your calculator may show you this. It is exactly the same thing because your calculator prefers to have the square root in the numerator rather than the denominator. But it is the same. Yes.
And in that second round of grade,
Yes.
if the factor is 5, why is either the first or the second time or 1 is square root 50 and otherwise
So remember, 5 in front of the square root 2. I have to take the 5 in, which is actually 25, into the square root. Times 2 is 50. So it's not just 2 times 5 giving me 10. Checking this calculate, and would I need to check the other 45? Is it going to change anything? Definitely not. Okay. Checking in the smaller triangle, 1 over square root 2. One over square root 2, and 1 over 1 is 1. And this, just a reminder, your calculator might give you that. So as a summary, the summary you definitely can write now, but as quickly as possible, please. Sine 30 will always be 1/2. I will. Sine 45 will always be 1 over square root 2, and sine 60 will always be square root 3 over 2. Cos 30 will always be square root 3 over 2. Cos 45 will always be 1 over square root 2. And cos of 60 will always be 1/2. Tan of 30 is always 1 over square root 3. Tan 45 is always 1. And tan 60 is always square root 3 over 1. So please, as quickly as possible, you can make it neater later. While you are writing, I will take those pictures for you.
Another question I have, will the 45 degree always be an isosceles triangle?
Will always be an isosceles, yes. Because remember, if one is 45 and it has to be a right angle, the other one will have to be 45 to make 180. Okay, so we obviously needed to know that to be able to do what comes next. Now I'm going to, whenever you see a special angle, I want you to cut it and replace it with what that fraction is. Okay, Erin, you write way too neatly, that is why it takes so long. Anyone else busy with the board? Yes, I did. I've sent it as well. Okay. So whenever we see the special angle, we replace it with the fraction. So sine 60 is? We can obviously look it up right now. Tan 45. Cos 30. And I'm just multiplying with normal numbers. Top with top, bottom with bottom. I'm just making that a fraction so that I know square root of 3 times 1 is square root of 3. Square root of 3 times square root of 3 is square root of 3 squared, just cancels the square, is 3. 2 times 1 is 2 times 2 is 4. And that's it. So now what you need to practice is remembering that 60, 45, and 30 are special angles that need to be cut and pasted with the special fractions. So I'm only going to give you 2 easy ones, 3 difficult ones. One easy, one difficult, and one with reduction. Okay. Because we only have a few minutes. So I'm going to rewrite it. I will send a picture of this for you to practice more in your own time. And I will obviously send a memo of it for next week when you're at home.
Ma'am, can you take a picture of the other one as well?
What I'm going to do is I'm going to scan this whole package and send it in the group. Then you'll have everything that we should have done. Okay, so I'm going to do this number 6 here. Tan squared 60 degrees, special angle. 2 sine 30 degrees, special angle. Tan 45 degrees, special angle. That's how I want you to train your brain. Okay, it's tan 60. For now, we're still going to have to look it up. Square root 3. And it is squared. 2 sine 30. Sine 30 is, I think it's a half. I've even forgotten my ratios, a half. And tan 45 is just 1. Square root 3, 2 squared is 3. 2 times a half is 1. Minus 1, my answer is 2. I'm going to do number 16, where I'm going to add some divisions now. Okay, tan squared 45, special angle. Sine squared 60, special angle. Sine 30, special angle. Cos 90, also a special angle that we learned the last time we were here. So right now, I just really want you to focus of what I'm doing. You can write all of it down later on. Tan 45 is equal to 1, and it is squared. Times by sine 60, which is square root 3 over 2, and it is squared. Sine 30, which is a half, and cos 90, which I can't even remember right now, is 0. Can I go any further? Why not? There's nothing I can cancel, but I could multiply out. But would it even be worth multiplying out? What must we always be wary of when we have a fraction? Look at your denominator. There can never be a 0 in my denominator. So this, I don't even have to do any extra work, will be undefined. Please remember 0 can't be in denominator. The bell's probably going to ring. I want to do one more reduction before we leave so that you can at least try it tomorrow. So what I am about to do now is the kind of question you should be working towards, because that's what you will receive. Okay? Reduction and special angles together. I'm going to do quite a difficult one. Okay, starting with my first one. Forget the fact right now that it is squared. 135 is in which quadrant? Positive or negative cos? Negative. My cos would be 180 minus what gives me 135? 45. Sine 270, which quadrant? Quadrant 3, positive or negative? That would be 180 plus. 180 plus what? 90 degrees. Sine 240, which quadrant? Positive or negative? 180 plus what? Tan is in which quadrant? Tan 150 in which quadrant? Quadrant 2, positive or negative? 180 minus what gives me 150? Special angles. So this would be negative from the negative. Cos 45, which is 1 over square root 2. So protecting that negative. Negative 90, so sine 90 is 1. With the negative would be negative 1. Sine 60 is square root 3 over 2, but it is negative, so leaving the negative there. And lastly, tan 30, which I forgot to write there. Tan 30 is square root 1 over square root 3, but it is negative. Negative times the negative is positive. Negative times the negative is positive. 1 over square root 2 times 1 would just be 1 over square root 2. Square root 3 times 1 is square root 3. And 2 times square root 3 is 2 square root 3. And we can still simplify further. In this fraction, square root 3 cancels. So we have 1 square root 2, tipping and timesing, times 2 over 1. So my final answer, 2 over square root 2. So that is as difficult as I would give it to you now. So I'm not here tomorrow. I will photocopy stuff for you. Just go through your notes. It will be special angles, reduction, and equations. Special angles, equations, and reduction. I'll send a picture of this as well. I'll also scan in everything that I've written for you guys, put it on the group, and I will also load all 4 videos of this week today still. Okay.